Hello. So this is lecture number 26, Physics 112. I am going to review on simple circuits. So the simplest circuit that we can draw is this. I have one resistor and I have one battery, and resistors are, let's say resistance R is given as let's say 8 ohms. Okay, and the battery is given as V is equal to 16 volt. What I want to find is the current in this circuit, and this is the short node and this is the long node. The long node is a positive one. The current is flowing in this direction, I. So I want to find the current in this circuit. So we always use this ohm, this law, V is equal to IR. We call it Ohm's law, and V is the voltage source, the battery. I is the current, R is the resistance. So then I want to find I is equal to V by R. So V is 16 volts, R is 8 ohms, the answer is 2 amperes. Okay, so that's 16 volt by 8 ohms, so I get 2 amperes. So very simple. Okay, now how can I make this circuit more complicated? So the way I want to approach is I want to make this a little bit more complicated, okay? So in order to do that, then this single resistor R is no longer one resistor, but I'll make it to be 2. So let's suppose the starting resistors are like this. I have 2 resistors, R1 and R2. And R1, and let's suppose R1 is 4 ohms and R2 is also 4 ohms. Let's call it R1, R2, and the voltage at in the battery is 16 volts. So I still want to find the current. Now there are 2 resistors, so I want to find in the current in each resistor and also the voltage drop through R1 and the voltage drop through R2. So before we do any calculation, first of all, think about this. Since these are in series, that means the same wire going through this resistor and this resistor, so that means the current for R1 and R2 will be one and the same current, right? There's no branching off of the current, right? Same current going through R1, same current going through R2. Another thing is, this is battery total voltage is 16 volt. So then the voltage drop through R1 plus voltage drop through R2 must add up to 16 volts, all right? Okay, so these are the things that we should know. First of all, in order to find the current, I have to find the equivalent resistance of this. Then let me draw the circuit. If we redraw this R1 and R2 together as one equivalent resistance, resistor, let's call it R total, right? And this is V, this is 16 volts. And the current will be going through here, right? So the current is here. So I want to find the current through RT. In order to find that R total, I must first find what RT is equal to R1 plus R2. Why is that? Because R1 and R2 are connected in series. So that's very simple. That is 4 ohms plus 4 ohms, altogether 8 ohms. Why did I choose 4? Because I just want to make sure the answer is the same as before, right? You could use any numbers you like, actually. So the total resistance in this one is now 8 ohms, right? So this is the total resistance, or you can say equivalent resistance to these two, all right? So now it is 8 ohms. So now you see this problem is exactly the same as the previous one, right? Identical now, right? So now I can find the current going through this R total. And so I is equal to V by R, and V is 16 volts. And this R right now is R total, so which is equal to 8 ohms. So the answer is again 2 amperes. Now, there is something new here because there are two resistors after all, right? But the current going through them is the same, so which is 2 amperes. But the voltage drop through R1 and voltage drop through R2 must add up to 16 volt. We just want to check. Okay, so how do I find voltage drop through R1? Very simple. V is equal to IR. That's Ohm's law. We always like that. And then voltage drop through R1, so let's call it V1. And the current through R1 is the same as I, so I'll just write I. But the resistance here is R1. So I is 2 amperes from above. R1 is 4 ohms. So altogether 4 times 2, I get 8 volts. So the voltage drop through R1, or voltage drop from here to this point is now 8 volts. Now the next thing is I need to find the voltage drop through R2. So that is V2 is equal to IR2. Again, let me emphasize that I use the same I because the same current is going through R1 and R2. So here again I get I is equal to 2 amperes. R2 happen to be just 4 because I gave that number. If it is for some other number, I would use that other number. And then now we have 8 volts. So you see V1 and V2, the voltage drop through R1 and voltage drop through R2, both are 8. When you add them up, you get 16, which is equal to this 16 volts. All right. So now we found everything. Now let me find something else. So I want to find the power dissipation in each resistor. If I want to find power has several formulas. One is P is equal to IV. But we know that V is equal to IR. So I can substitute for V, and then I get P is equal to I square R. That's one formula. P is equal to IV is 1. But V is equal to IR, that means I is equal to V by R. So for I, if I substitute V by R, I get P is equal to V squared by R. So I have 3 expressions for the power dissipation. P is equal to IV, P is equal to I square R, P is equal to V squared by R. Now let me find the power dissipation in the whole thing. So I might as well use this RT and current I. If I do that, I can use I square R. Or if I use the current and the voltage, then IV, I can use that. So you can use any of them. So let me use the first one, P is equal to IV. So if I use P is equal to IV, I is equal to 2 amperes, that's a total current, I know that. And V is, we know that that's 16 volts. Multiply it, I get 32 watts. Let me use the second formula. P is equal to I square R. So I square is 2 ampere squared. And R is 8 ohms. And 2 square is 4. 4 times 8 is 32 watts. So you see we get the same result. And I challenge you to try this one and see if you get the same result. Okay? Now, if I want to find the power dissipated in R1 or R2, what do? Well, again, we have those three formulas. So let's suppose I want to find power dissipation in resistor R1. P1 will be I1 V1. Or I can also use I1 square R1. Or I can also use V1 square by R1. Right? So I can use any of these formulas. P is equal to IV, P is equal to I square R, and P is equal to V square by R. All right? So let me use the first one. So P1. I1 is, we found that I1 is the same as total current I, which is equal to 2 amperes. And V1 is the voltage drop through the first resistor, which is 8 volts. If I multiply it, I get 16 watts. Okay, now I can do the same thing for P2. I'll get P2 again is 2 amperes because the same current, and voltage drop is 8 volts. We have calculated before here. V2 is equal to 8 volts. Then I get 16 watts again. So then the total power dissipation is P is equal to P1 plus P2, which will give me 16 plus 16, 32 watts, which is the same as P4, you see, which is the same as power dissipation calculated from this circuit. All right? Okay? So that's how we get the power dissipation. And now the next thing is, let's see if we can make this circuit different. So instead of having these two in series, now I'm going to make them in parallel. Let's see, what do I mean by that? I'm going to make this one resistor here and one resistor here. Like this. So again, this will be 16 volts. This is R1 and this is R2. Okay? So I'm going to make R1 is equal to R2 is equal to 16 ohms. All right? Now, why do I want to do that? Well, because you'll see in a second. So first of all, I need to find equivalent resistance for this loop. So in order to do that, in order to do that, let me redraw this. So after I make equivalent resistance for this one, then I'll have only this. Let's call it R12 because equivalent resistance for R1 and R2 connected in parallel. This is my 16 volt, and the current will be going up, right? So current will be here. So first of all, since R1 and R2 are in parallel, in order to find R12, I have to do R12 is equal to 1 by R1 plus 1 by R2. The reason is because they are connected in parallel to each other. And R1 is 16 ohms, R2 is 16 ohms. So 1 by 16 plus 1 by 16 give me 2 by 16, which is 1 by 8. So 1 by 8 ohms. So R12 is equal to 8 ohms. You see, so I have to remember that this is 1 by R12, so I have to flip this over so that I can get R12 is equal to 8 ohms, right? So now I can find the total current again, and the total current V is equal to IR, and then I is equal to V by R. So now I can get V is 16 volts, and R is equal to 8 ohms, so I is equal to 2 amperes. Okay. Now the current is 2 amperes, and the funny thing is that this 2 amperes is going to split between R1 and R2, right? So the voltage drop between R1 and R2 is simply 16 volts. So V1 or V2 is equal to 16 because the voltage drop for resistor 1 or resistor 2, both of them are same. All right. So now I can find current through resistor 1 by using V1 is equal to I1 R1, and V1 is 16 volts. I1 is the one I want. R1 is 16 ohms, so I1 is equal to 1 ampere. Similarly, you can find that from V2 is equal to I2 R2. You can find that I2 is also equal to 1 ampere. And you see that I1 plus I2, they add up to 2 amperes because I1 is 1, I2 is 1, and this is equal to the total current I, right? And power dissipation you can find same way using this formula. P is equal to IV or I square R or V square by R. All right? Okay. Thank you.